In this video, we are going to cover integer exponents, specifically working with negative exponents, and also scientific notation, because that tends to be where we see negative exponents showing up fairly frequently. So kind of two halves of this video here for today. Now, starting off with negative exponents, we have our core definition of what these are and what this actually does to the thing it's raising to a power. So if n is an integer, we're assuming in this case it could be a positive or negative, whichever, then if I have something, let's say a, raised to the negative n power, that results in 1 over a to the positive n power. Similarly, if we have 1 over a to the negative n power, that's going to become a to the n power. Way of thinking on this is kind of a simplified way is the negative in the exponent spot will flip where the base of that exponent is in the fraction. Meaning, looking at this first instance that we're starting off with, the a is in the numerator of a fraction. This would be a over 1. The negative exponent moves the a into the denominator spot, and then that's all the negative exponent does. In contrast with our second little quick example and definition here, we have 1 over a to the negative n power. And when I apply that negative exponent, that a moves from the denominator of the fraction into the numerator, giving me just a to the n as my final answer. So with this, I want to give a massive warning. If you are writing and taking notes down, I would recommend that you are doing that. Put a big red star, warning, highlight, circle, whatever you need to do with this. A negative exponent does not inherently change the sign of its base. A lot of people think that negative exponents automatically change other signs in the problem. It does not do that. It only flips where the base is in the fraction. That's it. We have that quick note right down here as a reminder about this. So whenever you see a negative exponent, take a pause, and all that negative does is just flip things. That's it, nothing else. Now, extrapolating from there, let's say we have a quotient, a whole fraction that's being raised to a negative exponent. Well, we have a property for that, and instead of just moving where the location of one thing is in a fraction to the opposite spot, numerator to denominator, or denominator into numerator, if I have an entire fraction that's being raised to a negative power, and it's generally written to be inside of parentheses when this is happening, then the entire fraction itself is going to flip. The entire numerator becomes the denominator. The entire denominator becomes the numerator. It all stays contained within a set of parentheses, and the negative sign on the exponent vanishes. So when we see this showing up, negative sign in the exponent just quote-unquote flips the fraction. That's it. It does nothing else to the base. Again, a lot of people want to go to it flips the fraction and it flips the sign of the thing. It just flips the base, just flips the fraction. That's it. So let's take a look at 4 examples here and see how this will play out and how we apply these two properties. For our first example, we are given 3 to the negative second power. Now, my recommendation, if you have something like this showing up and you know that you want to apply the negative exponent property, is just apply that negative first and then apply the number after that. So what I mean is this negative sign is going to flip where this base is in the fraction. So this is going to get rewritten to be 1 over 3 to the second power. Now that that negative exponent is gone, I can just work with 3 to the second power, which is going to therefore give me 1 over 9 as my final answer. I tend to find slowing down just a little bit with negative exponents tends to make it a little bit easier to track what you're doing from one step to the next and the next. And also, showing your work goes a really long way with that as well. In our second example, we have 1 over 4 to the negative third power. Again, If I'm going to apply that negative exponent, I'm just going to work with the negative sign first, which is going to flip where this base is in my fraction. So the 4 is going to go from the denominator spot into the numerator spot. So this is going to end up becoming 4 to the positive third power. So I just applied the negative, moved the location of its base, and now I have 4 to the third power. I can plug that into my calculator, and that's going to give me 64 for my final answer. Yeah, not too terrible here, but I do think taking an extra line to show that we've just applied the negative goes a very long way with making these a little bit more straightforward and easier to follow. For our third example, we are having a fraction inside of parentheses being raised to a negative exponent power. So I have the quantity negative 6m over n, all raised to the negative second power. Well, I'm going to apply the quotient to a negative exponent property, and that states that I'm going to take this fraction and I'm going to flip where everything is in that fraction. That's the only thing that the negative in the exponent spot does. So when I do that, the negative sign in front of the fraction stays the same, and the rest of the fraction flips. So this becomes n over 6m, and the exponent then becomes a positive 2. At this point in time, I can now write this out in multiple ways like we've done in previous videos to get to our final answer. I'm going to go ahead and expand this out just to show that these two things are multiplying together, or this is multiplying by itself just twice. And then we can multiply these fractions straight across and get to our final answer. A negative times a negative is a positive. N times n is going to give me n squared in the numerator spot. 6 times 6 is going to give me 36. And then m times m is going to give me m to the second power. I always look to see if I can reduce anything down, but I can't because I have two variables that are different. One's an n and one's an m, so I can't simplify this any further, and I now have my final answer. In our fourth example of some introductory problems with negative exponents, we have the negative quantity of 1 over 7 all being raised to the negative second power. Now again, I have a fraction inside of parentheses raised to a negative power. However, I have this negative sign out front here. This is not contained inside the parentheses, meaning it is not going to be affected by this exponent in any way, shape, and form. It's just going to sit here out front through the entire problem. So, dealing with the negative in the exponent spot, that is going to flip this fraction inside of the parentheses. So that's going to result in us getting negative, parenthesis, 7 to the second power. 7 to the second power is going to be 49. The negative in front does not change, and this is going to result in us getting a final answer of negative 49. Now that we have seen some examples and gone through properties with negative exponents, this means that we can no longer have polynomial final answers that contain negative exponents. We know how to work with them. We can do these rewrites as necessary to get to our final answers. So we now need to make sure we're keeping that in mind when we are going through and simplifying problems and writing out our final answers to those problems. As a reminder, these are all of the different properties that we have seen and we are going to be covering in this particular chapter. I would highly recommend that you pause the video here and write all of these down for yourself because we are going to be using them in our next set of examples, and you're going to be using them in a lot of the homework that you're doing. And I think having these all written down in kind of a quote-unquote cheat sheet for yourself goes a really long way with making these problems a little bit easier and remembering which properties are available to us and how we use them. So with that, let's use all of these properties to go through our next 4 examples of simplifying these given polynomial expressions. The first thing I would like to note as we go through our first example is that there are several routes that we can take to get to our final answer here. If you're someone who's in my class and you're watching this video, I do not care which particular method you would like to use or which option you would like to use as you go through these problems. If you are someone who's watching this kind of just at random on YouTube or anything like that, be aware that there are multiple routes that you can take to get to a final answer. If you're ever unsure as to what to use, always fall back on PEMDAS, our order of operations. That's always a good one to use as a guide for what to do with these problems, but we do have some flexibility within that. So for our first example, I'm going to show you two different ways that you could go through and solve this. Our first one, let's say we work with our negative exponent properties like we've been doing up until now. So I'm just going to rewrite x to the negative fourth power. That's going to make this become 1 over x to the fourth power, and that's multiplying with x to the 13th power. I can then multiply these two fractions together, and that's going to give me x to the 13th over x to the 4th. And now I can use my quotient property to subtract these exponents together, and that's going to give me x to the 9th as my final answer. Now you're more than welcome to use this method by doing some of the rewrites ahead of time if you would like to. You also have the option, and I want to show just this other option here as well, where we're not going to deal with the negative exponent first. We're noticing that I have two things multiplying together. So the bases are the same and they're multiplying together, which says I can use the product rule. The product rule would then have me take the two exponents, whatever they are, and then add them together. So I would get x to the negative 4 plus 13th power, and simplifying that down, I'm going to get x to the 9th. So we have two ways of working through this problem, and we're going to have two ways of working through most of these problems, or multiple options to go through these problems, and I want to just show that you have different routes that you can take to get to the final answer. With our second example, we have the quantity 2b to the third power, all raised to the negative fourth power. And again, with this example, like we saw with our first one, we do have multiple options on how we want to go through and work with this. It's kind of your choice on which of the properties you would like to use at which time, but more than anything else, pick one and then commit to that. For this problem, I feel like working with the negative exponent first is probably going to be the most beneficial, so I'm going to get rid of that negative exponent here. And that tells me I'm going to take everything that is the base of this exponent, which is everything in the parentheses, and I'm going to put that in the denominator part of a fraction. So this is going to become 1 over the quantity 2b to the third, all raised to the fourth power. And now I have two options. I could apply the product to a power property, or I could just expand this thing out and then multiply these bases together. I'm going to go ahead and use the product to a power property, and I tend to like to write this out as the first thing to the fourth power and then the second thing to the fourth power. So I end up getting, let's see, 2 to the fourth, I believe that's going to be 16. Yep. And then b to the third raised to the fourth power. That's using the power rule. That's going to give me b to the 12th. And here I have my final answer of 1 over 16 b to the 12th power. Now again, just showing one way that we could go through this, but as we saw with our first example, you do have a couple routes that you could choose to go through, but you should get to the same answer either way. Example 3 is another case where we have multiple routes that we can take, and a lot of the time we just need to pick which route and which property we want to use and commit to that. Noticing that we have a negative exponent, that does mean that the negative exponent properties are available for us to use. However, we also find that this whole thing is contained within a fraction, and the two bases of the exponents, 7 and negative 3, are the same. They both have a base of x, which means the quotient property is fair game as well. Now it's your choice on which one you would like to start with. Some are going to be faster, some are going to be slower than others. I'm going to go ahead and show both of those options right down below here. So let's start with using the quotient property, one that we've used quite a bit up until now and we're hopefully pretty familiar and comfortable with. So that says if I have bases that are the same and dividing, the exponents are going to subtract from one another. So that's going to create the instance where I have x to the 7 minus negative 3 power. The same as saying x to the 7 plus 3 power, which gives me x to the 10th. Let's make this a little bit nicer, stay consistent. There we go, x to the 10th power. Now I did throw in the added step of rewriting the double negative into a positive because I'm just not a fan of double signs like that. I think they're annoying, I think they get confusing, and so that's why I went and did that. Now let's say we take the other route where alternatively we go through and let's rewrite this thing so we get rid of this negative exponent. So that means that this denominator, x to the negative 3rd power, is going to come up to the numerator and the negative sign is going to drop. That's going to create the instance where we have x to the 7th times x to the 3rd power. And now I have the product property showing up. The bases are the same and multiplying, and that means that I can just write x to the 7 plus 3 power, which is the same as saying x to the 10th power, just like we did with our first process. Now, you might be noticing that, okay, there's two ways to do this. Is there one that I should pick over the other? Not really. Do which one is easier for you. Looking at our fourth and final example with using all of our integer properties, we once again have multiple choices on how we want to go through and simplify this expression down. I'm going to try and show both of them and go through them at a decent enough pace so that way we're not spending too long on this example. So for the first route that I'm going to take, I'm not going to worry about these negative exponents or apply any negative exponent properties. I see that everything is multiplying together, and so I'm just going to continue and multiply everything together in this problem. So I have 3 and negative 4 that are going to multiply together. That's going to go ahead and give me negative 12. I have x to the negative 5th power times x to the 4th power. That means I'm going to be able to apply my product property, which says that these exponents will add together. That's going to give me x to the negative 1st power. And then I have y to the 7th times y to the negative 2nd power. And once again, the product rule states that these two numbers will be adding together. 7 plus negative 2 is going to give me a 5. So I'm going to have y to the 5th power here. And now I've condensed everything down to just be a single coefficient, a single x, and a single y. As we noted, we cannot have negative exponents in our final answers now that we know how to work with negative exponents, so I do need to rewrite this x to the negative 1st power and put that in the denominator spot. So after a quick rewrite, I will have negative 12y to the 5th power being divided by x. And that's x is technically to the 1st power, but we don't need to write that in. It is assumed to be there. Now, a warning that I will give in this last rewriting step. I've seen many people think that this negative 1 is affecting the x and the 12 listed out here. This negative 1 only affects this x. The 12 isn't raised to anything other than 1. It's invisible there. So only this x is being affected by the negative exponent. But let's go ahead and take a look at the alternate route that we could take. That says, what if we work with the negative exponents first at the beginning of this problem and rewrite each of these things before we actually start applying the product or the quotient property or any of that? Let's go ahead and rewrite our first expression. So we have x to the negative 5th power, only the x is being affected, and that x is going to go to the denominator part of a fraction. So our first expression is going to become 3y to the 7th over x to the 5th. Then for our second expression, the y is being raised to the negative 2nd power, so that's the only thing that's going to flip. So I'm going to have negative 4x to the fourth being divided by y to the second power. And now I have two fractions that are multiplying together. I can multiply the numerator straight across. I can multiply the denominator straight across. When I do that, I'm going to get negative 12x to the fourth, y to the seventh in the numerator, and the denominator is going to be x to the fifth, y to the second. I can then apply the quotient property with the x's. Those are going to subtract, so 4 minus 5, that's going to give me a negative 1. The denominator has a higher exponent value with that, so that tells me that I'm going to have a single x left over in my denominator spot. So I have x down here. Y to the seventh divided by y to the second. I'm applying the quotient property yet again. 7 minus 2, that's going to give me 5. So I end up getting y to the fifth power in my numerator spot. And as we can see, we are once again getting the exact same answer as we did with our first method. Both of them work. Just make sure you are correctly applying the exponent property that you are choosing to use from one step to the next. And again, I think that is easiest to do if you are writing out and showing your work from one step to the next in this process. The second half of what this section covers is scientific notation. Now, we're not going to go into a lot of very in-depth information about scientific notation. We just want to know and learn how to go between decimal notation, what we're used to normally seeing, and scientific notation, and how to go back and forth between those two forms, and we'll do some basic operations with scientific notation. That's the extent of what we're going to be doing with that for this video and for my class, if you are in my class watching this video. And we have our core definition of what scientific notation is, and it follows the form of a times 10 to the nth power. A generally represents a number, and that number is greater than or equal to 1 and less than 10. So it's something between 1 and 9.99999, repeating on forever. This is going to be important because it's very useful in telling us where am I converting from decimal scientific notation into, and how I'm moving back and forth between these two terms. The n, the exponent here, can be a positive or it could be a negative for our final answer. This is the one instance where we have an exception where we can have negative exponents in our final answer. I know in our previous examples we didn't allow that anymore. This is the one exception where we will still allow that to be the case. So let's start with converting from decimal notation into scientific notation. Decimal notation is what we're used to seeing up until now. So we're just given some number, however big, small, whatever it may be. What we're going to be doing is we're going to move the decimal point so that the first factor is greater than or equal to 1, but less than 10. We essentially want to make this a value for ourselves, remembering that a is greater than or equal to 1 and less than 10. We want to count how many places we moved, and that's going to be that n, that we moved the decimal point. We then write down this overall number as a product of whatever we converted this thing into times 10 to a power. Now what that power is going to determine on one of two things. If the original number was greater than 1, then that n that we counted earlier is going to be a positive n for 10 to the power. If the original number was between 0 and 1, meaning it's a really, really, really small decimal, then the power is going to be 10 to the negative n power that we counted out. So we'll see two examples of how we go through that for decimal and scientific notation. I do want to go through the opposite here, and then we'll do all four of these examples in a quick row. So if I'm converting from scientific notation into decimal notation, we're basically just doing the reverse of what we did here in this process. We want to determine the exponent, n, that has 10 being raised to a power. We're then going to move that decimal point n places, and we're going to add zeros into any open slots that show up as necessary. And I'll clarify and show you what I mean by slots as we are going through this process. We do want to note if the exponent is a positive or a negative value, because that is going to determine which way the decimal is going to be moving. If the exponent is positive, then we're going to move the decimal that number of places to the right. And if the exponent is negative, we're going to move the decimal that many places to the left. And that is the full extent of what we are going to be doing with just converting between these two forms. So we'll start with converting into scientific notation with our examples up here, and then we'll start with converting into decimal notation with the examples that we have listed right down here. Looking at our first example with converting into scientific notation, we're starting off with 48,300. With our process, we are told to move the decimal point, the number of places to make this number between 1 and 10. So I generally like to rewrite these things down below here. We want to label, here's where our decimal point is. It's always at the very end of the whole numbers if that's what's listed to us. Now I need to convert this thing to be a number between 1 and 10, so I need to move this decimal point over in this direction. And it's going to end right here between the 4 and the 8. So that means that this thing is going to end up becoming 4.83 times 10 to the, and now I need to figure out what is that power going to be. Well, our second step says to count the number of decimal places that we moved. So I went over 1, 2, 3, 4. So I moved over 4 places. And the original number was greater than 1. So that means my exponent up here is going to be a positive 4. And therefore I have my final answer of 4.83 times 10 to the 4th power. For our second example, we are starting off with the number 0.0129. And I'm told to convert this thing into scientific notation. Once again, I'm going to rewrite this number right below where I'm starting, because I want to be able to track where the decimal changes are happening. And I need to rewrite this thing to be a number between 1 and 10. So I'm going to take the decimal and move it over 2 places. And I'm now going to get this thing rewritten as 1.29 times 10 to the, and now I need to figure out what this exponent is going to be. I move the decimal 2 places, so it's either going to be n to the 2nd power or n to the negative 2nd power. Looking at our process, our beginning number, the original number, was between 0 and 1, which tells me that I'm going to have a negative exponent here for my final answer, which means that my final overall answer is going to be 1.29 times 10 to the negative 2nd power. Refer back to that process as much as you need to as you're going through and converting these things. With our next pair of examples, we're going to be going through and converting into decimal notation now. So following my process, I'm going to determine what the exponent is. In this case, it's 4. So that means this decimal is going to be moving 4 places either to the left or 4 places to the right. We determine which direction it's going to be moving based on if this exponent is positive or a negative number. Looking at our process, if the exponent is positive, then the decimal is going to move to the right. So I'm going to rewrite 9.25 down below where I started. And I'm going to move this thing 4 places to the right, and we can just count that out. So we're ending right here. And notice how I have some blank slots in between here, or blank spaces. This is what I was referring to earlier with those in our process. These are going to get filled in with placeholder zeros. So I'm just going to write 0 and 0 here. And that gives me my final answer of 92,500. It's as straightforward as that. Just make sure that you are double checking the exponent and its sign, and then going in the correct direction, left to right, with that decimal point. For our second example of converting into decimal notation, I have 7.5 times 10 to the negative second power. I'm once again going to rewrite 7.5 right down below where I originally have my problem. I'm counting the number of exponents that I have, so I have 2, which means this decimal is going to either move 2 to the left or 2 to the right. I check the sign of this exponent and see that it is negative. That tells me that this decimal point is going to move 2 places to the left. And again, refer to the directions as necessary when you are going through these problems. So I'm taking the decimal, I'm going over 1, 2 places here. I have a single placeholder 0 filling in, and I like to put another 0 in front of the decimal point here, especially so I know it's some number between 0 and 1. And when I rewrite all of this out, I get a final answer of 0.075, and then I am done. Our final part in this video today has us working with multiplying and dividing scientific notation numbers. Now I'm going to specifically look at and show 2 examples of division with scientific numbers because I think this one is a little bit trickier to wrap our mind around and visualize how we get to the example. The multiplication one is very straightforward, as the parts here would suggest. So what we want to do first is do the specified operation with the leading a value part. Meaning, if I have 2 things multiplying together and they're in scientific notation, multiply the leading numbers together first. If we have division, divide those leading terms together first. We then do that exact same operation, either multiplication or division, with 10 to the n value part. So if I have 10 to the m times 10 to the n, then I apply the product rule and add those exponents together. If I have division, then I'm going to have 10 to the m divided by 10 to the n, and I'm going to apply the quotient rule and get my final answer written out here. So we'll take a look at these 2 examples really quickly with division, and then that'll wrap things up for our stuff with this material. With our first example of dividing with scientific notation, we have 8 times 10 to the 4th power divided by 2 times 10 to the negative 1st power. So from here, my recommendation is that you split this up into just the numbers dividing, and then just the 10 to the 4th and 10 to the negative 2nd power, or negative 1st power dividing. Make this 2 a little bit better. From here, we're just simplifying this first part. 8 divided by 2 is going to give me 4. And then for the second part, we have 10 to the 4th divided by 10 to the negative 1st power. I'm going to use the quotient rule, which says I take the numerator minus the denominator. So 4 minus negative 1, that's going to give me 4 plus 1, which makes this 4 times 10 to the 5th power for my final answer. In our second and final example with multiplying and dividing scientific notation, we have 2 times 10 to the 2nd divided by 4 times 10 to the negative 2nd power. Once again, like my first example, I'm going to split these things apart. I'm going to have 12 divided by 4, multiplying with 10 to the 2nd power divided by 10 to the negative 2nd power. And I'm going to work through and simplify each of these individually and then bring them together in my final answer. So 12 divided by 4, that's going to give me 3. 10 to the 2nd divided by 10 to the negative 2nd is going to have me using the quotient rule. So I have 2 minus negative 2, which is the same as saying 2 plus 2, which means I'm going to have my final answer here of 3 times 10 to the positive 4th power. Bringing everything back together, we're going to go through a quick summary and recap of everything that we covered in this video because there's a lot within it. We worked with our definitions of negative exponents and quotients raised to a negative exponent, Remember that all a negative exponent does is flip a fraction or flip a base from where it is in a fraction. A negative exponent does not change the sign of its base in any way, shape, and form. We went through 4 examples of just applying these two properties, and then we saw some examples of how we can apply all of our exponent properties to some different examples listed down below here. I would again highly recommend pausing the video and having these properties written down for yourself, because they do show up quite a bit, and we kind of mix and match those with different problems that we see in the order that we do them in, like we saw with our 4 examples here. We then worked with scientific notation. We had our definition of that and how we convert between decimal notation, our standard thing that we're used to seeing, and scientific notation, as well as how we convert between scientific notation into decimal notation. And then last but not least, we did a few examples of dividing using scientific notation, because I do think it is the slightly trickier one with how to rewrite and work through these. Multiplication, though, we're just multiplying the two numbers together and then multiplying the tens together using the product rule. And that's going to do it for everything in the 6.7 material.